So we're going to look at bonding. There are two specific bonds that we're going to look at over the next couple of videos. Um, and there's actually three we're talking about in this group of lessons, but this slideshow has to do with two in particular. So how do atoms come together? So we've talked about how they become ions. Now these ions are going to come together to make bonds. So everything is made up of atoms. These atoms will combine to make compounds if you're dealing with ionic bonds, molecules if they're covalent, or alloys slash crystals if you're dealing with metallic. All bonding occurs because electrons move in some way to make the magic number 8 on the outer ring of the atoms involved. Okay, we are trying so hard to get to that magic number 8. So there are three types of bonds. Ionic bonds are when atoms are bonded by giving and taking electrons to create ions with charges. The opposite charges will be attracted to each other and they occur between metals and nonmetals. They're the second strongest bond. Then you have covalent bonds. These atoms are bonded together by sharing, and they occur in nonmetals and they're the weakest bond. And then you have metallic bonding, which is metal atoms are bound together by creating a sea of delocalized, free from one another electrons. They are moved and shared. This gives them certain properties, which we're going to talk about in another video, and they're the strongest of the bonds. So some properties between covalent and ionic. Ionic bonding is high melting and boiling points. They're brittle, which means they're easy to break. They're hard. It's able to conduct electricity when it's in solution, and they dissolve well in water. Covalent bonds have lower melting and boiling points. They're flexible. And usually because I say flexible, there's not a lot of solids we're dealing with, but because a lot of our nonmetals are gases, but when they are in solid form, they're flexible. They're soft. They do not conduct electricity when in solution. They don't dissolve well in water, but they are more flammable. It is very easy to catch them on fire. So how do bonds happen? So let's look at ionic bonding. Okay, how they move from how the electrons move to create a bond. So ionic bonding, we are giving electrons between metals and nonmetals. It's like the transfer of electrons. A metal becomes your cation, it's the positive charge. Your nonmetal is your anion, it's the negative charge. And we're trying to get to a charge of 0 when we're dealing with this. Okay, so we want to get to 0. So valence electrons on the move. When valence electrons move, ions are formed and ionic bonds are made, and our Lewis dot structures can help us see how they bond. So I have sodium, which has 1 electron, and I have chlorine, which has 7 electrons. Okay. My sodium is going to give up an electron, and it's going to move to chlorine. Okay, and now my sodium is positive, and he's attracted to my chlorine, who's negative, and that's kind of how my structure would look if I was doing a Lewis dot structure. Okay. When the valence electrons, like I said, when they move, we're going to see that. So here we have another one. We have calcium. It has 2. And he meets phosphorus. And phosphorus has 5. Okay. And so calcium is going to give up his 2 electrons to try to make phosphorus happy. And it's not enough. So calcium's going to pull in his next buddy, which is another calcium. And he has his 2 electrons. So he's going to give up an electron to phosphorus. Okay, and so my phosphorus is really happy. My first calcium is happy, but my second calcium is not completely satisfied because he doesn't have 8 electrons on his outermost ring. He has 1 that's causing his ring to be stuck. So phosphorus is going to bring in his pal phosphorus, and calcium is going to give up the electron. So now my 2 calcium are happy, my first phosphorus is happy, but my second phosphorus is still unsatisfied because he needs 2 more electrons. So the calcium say, well, we have 1 more buddy. So they're going to bring in their other buddy, calcium. And again, he's going to have 2 electrons. And these 2 electrons are going to go to phosphorus. Okay. And so now everybody has either 0 electrons on their outermost on the ring that they were first originally there, which means that ring disappears. And so they have 8 on their electrons inside, the electron ring inside, or they have 8 on the outside like these phosphors have. And so I would make something that looks like this. I have 3 Ca, so I would write that, and I have 2 P, so I'd write that. And that's my formula. So like I said, when these electrons move, we make charges or oxidation numbers. These charges can be used to write our formula and the name, which we're going to talk about later, as the compound is made. So to determine this, we're going to do a crisscross method, which we can say, are we going to sandwich, okay, which means we don't need subscripts, or crisscross applesauce, because we're going to need subscripts. You don't need subscripts if your numbers match. If your charge is 2 plus and your charge is 2 minus, those numbers match, not the symbols, I'm just talking about the numbers. So we can sandwich them together. If you have a 2 and a 3, those numbers do not match. You're going to crisscross applesauce, okay, and which we're going to look at. Okay, so in my sandwich method, my numbers again are the same. So I just sandwich the symbols together. So I have sodium, which has a 1 plus. I have chlorine, which has a 1 minus, because remember, chlorine has 7, so to get happy, it takes on 1 electron. So I just sandwich them together with sodium chloride. Applesauce means that my numbers are different, and I'm going to crisscross the numbers to the other symbol and then push them together. So I have calcium, which is 2 plus. I have phosphorus, which is 3 minus. Okay, 2 plus means I give away 2 electrons. 3 minus means I have to bring in 3 electrons. Okay, they don't match, so I'm going to crisscross. My 2 is going to come down to my P. My 3 is going to come down to my Ca. And I have Ca3 2P. And that's what we saw in the last section visually with our Lewis dot structure. So in your notebook, the steps are write each symbol for the element. Okay, so I'm doing oxygen and hydrogen. I'm going to write the charges for each element. Hydrogen has 1 electron it's willing to give up. Oxygen has 2 electrons that it needs because it has 6, and so it needs 2 more to get to 8. Remember magic number 8. So then we're going to crisscross. Okay, you can crisscross. You get 2 minus or 1 and 1 plus, and then you would drop your charges. And you get H2O. Either way that you do this, crisscross applesauce or in sandwich method, or this method right here where you're always crisscrossing, it doesn't matter, you're going to get the same answer. Okay? So that's all I have for ionic bonding, and we will pick up with covalent bonding in the next lesson.